All right. Oh my gosh, that's such a good book. Okay, sorry. All right. At the beginning of 2010, landfill contained 1,400 tons of solid waste. The increasing function W. All right, so when I read that phrase, I like to circle this because there's probably a reason they're telling me that, okay? They don't typically give us like extra information and a prompt and a free response prompt, like distractor information. So I want to remind myself that that word's there. So the increasing function W models the amount of solid waste stored in this landfill. Planners estimate that it will satisfy this differential equation for the next 20 years. So W is in tons, time is in years since the start of 2010. All right, so at the beginning of 2010, that is time equals 0, okay? And at time equals 0, W equals 1,400. So guys, a lot of times, we've been doing a lot of differential equation questions without context. Okay, it's just some generic function x, y. So here we have context, okay? So what's our independent variable in this context? T. And what is our dependent variable? W, okay? All right, so part A. Use the tangent line to the graph of W at time equals 0 to approximate the amount of solid waste. And guys, that's W. So to approximate W, okay, at the end of the first 3 months. And they told you, by the way, that's 3 months is 1/4 of a year. Okay? All right, so use the tangent line. If I'm going to use the tangent line, I need the tangent line equation. So what do we need to write the equation of any line? All right, so I start there. Point, slope. All right, so remember, we're not dealing with generic function x, y. We're dealing with time and the corresponding W. All right, so we're going to write this tangent line to the graph of W at t equals 0. And what was the amount of solid waste at time 0? Good, 1,400. And guys, how do we find slope of a tangent? How do I find slope at a point? The derivative. All right, so dw dt, okay, evaluated at this point. But this is a situation where that rate of change only depends on W. All right, so 1/25th. W minus 300, so 1,400 minus 300. All right, this was a non-calculator question. So I don't have to do too much of the arithmetic here. I would go ahead and say 1,400 minus 300 is 1,100. And just maybe leave it like that. I mean, you could go further, but we don't have to. All right, everybody good? All right, so now I'm going to write the equation of a tangent line. Y equals our slope, 1,100 over 25, times the quantity, t minus 0, plus 1,400. No. We don't want to call this W because we are not writing the equation of W right now. We're going to do that in part C. So I do have to call this, if I could use an X right there instead of T, no, they won't take off. But don't call this W. Okay. All right, so now it says use the tangent line, okay? Use this tangent line to approximate W at T equals 1/4. So I want to be clear in my communication. I don't want to use an equal sign there. That's misuse of equality. And we are making a substitution. So t equals 1/4. 1/4 minus 0 is just 1/4 plus 1,400. Now, can I leave my answer like this? As long as I put my units, that's tons. But this works out really nicely. 25 times 4 is 100. 1,100 divided by 100 is 11. So I could just clean that one up. Tons. So guys, that part A by itself is worth 2 points. So if you could have talked yourself through part A, you would have beat the average on this question. All right, everybody okay? Okay, so we are doing an approximation for W, okay? Because we're using the tangent line to approximate a value of W, okay? So here, I thought you were asking like why I need one here versus why I don't need one there. Okay. So yeah, that is, if I did put an equal sign there, it's called misuse of equality, and most of the time it'll cost you a point. Any other questions? All right, can I erase this? All right. So part B, find the second derivative of W in terms of W. And then we're going to use that second derivative to determine if our approximation in part A was an underestimate or overestimate. All right, but first piece, find the second derivative. Okay, so find the second derivative of W with respect to time. Okay, so why don't you try that real quick? Take about 30 seconds and take that second derivative. So basically the second derivative, we're taking the derivative of dw dt with respect to t. I think you copied it down wrong. You meant to put 125, right? 1 over 25. Okay, now, when I worked this problem for the first time in 2011, I would not have gotten full credit on this piece. Okay? I made a mistake on this one, but I learned from my mistake. I did not do that same mistake in 2012. Okay, so, now guys, it does say, you gotta be careful here, we're not taking the derivative with respect to W. We are taking a derivative with respect to T, okay? If I was taking a derivative with respect to W, my answer would just be 1/25th. dw dw, so 1/25th. But we've got to remind ourselves, we are taking the derivative with respect to t. All right, and I would kind of distribute here. I would look at this as 1/25th w minus 1/25th of 300. And then differentiate term by term. So what is the derivative of 1/25th w with respect to t? 1/25th. There you go, dw dt. A common mistake was just putting 1/25th, okay, thinking you were taking the derivative with respect to w. And then guys, what's the derivative of any constant? 0. All right, now, can I stop here? Why not? Okay, because we're right here, guys, in terms of w. And I missed that, okay? I stopped right here, and then I went on to answer the second part of this part B. But we can't stop here. In terms of w, guys, dw dt is a whole different quantity. Because a lot of kids say, well, it is in terms of w because there's a w right there. No, it's in terms of dw dt. So we do have to go further and make a substitution. 1/25th. All right, and what is dw dt? W minus 300. And now we have the second derivative with respect to t in terms of w. All right. Now, after doing all that work, we can't forget that there's a second component to this part. So use that second derivative to determine if our answer in part A was an underestimate or overestimate. So what do we need to consider here? How do we determine when a tangent line approximation is an overestimate or an underestimate? I know what you're thinking. Yeah, you're thinking of a different thing. That's what we are. That's the question we're trying to answer. So how do we do that? So I like to draw pictures. So think about this, guys. If I have a function, I know this is an increasing function, but it could be increasing concave down or increasing concave up. So guys, if we have a curve that's concave down and I draw a tangent line anywhere on that curve, pretend I touch the curve, that tangent line is above the curve. Okay, so any approximation using that tangent line would be an overestimate for an actual function value. If I have a curve that's concave up and I draw a tangent line, my tangent line would lie below the curve. So any approximation using that tangent line would be an underestimate. All right, so I need to determine if this function w that we don't yet have is concave up or concave down on this interval from 0 to 1/4. That's why we have the second derivative. Okay, that's why they said, hey, find it and then use it. Correct. So what tells me if a curve is concave up or concave down? I liked your little fun box thing that you had. Is it in your binder? That little tiny little fun box you had. Yeah. Okay. What positive or negative?
Is it positive? Is it
second derivative. Okay. We're looking at the sign of the second derivative. All right, guys. Talk to me about w. What do we know about w? Okay. Did you hear what he said? If w is greater than 300, then I know this quantity will be positive. Multiplied by 1/25 still positive. Multiplied by 1/25 still positive. So talk to me about w. What do we know about w? There you go. At time 0, w is 1400, and it is strictly increasing. Okay? So I would make the statement, since w is going to be greater than or equal to 1400. Okay, it starts at 1400 and then increases. The second derivative of w with respect to time is positive. And guys, when we talk about concavity, and we're trying to answer this question about a tangent line approximation being under or over, we've got to speak about the concavity on an interval. Okay, from the interval, starting at the point, the center of approximation. So we built our tangent line at time 0, and then we used it to approximate a value at t equals 1/4. So I want to speak to the concavity on that interval. So for time between 0 and 1/4. So now what do we know? W is concave up, so my tangent line approximation, underestimate. So then I can say, so since this is true, approximation in part B, or part A, is an underestimate. Now I could say W is concave up, therefore approximation is an underestimate, but I don't need to do that. In fact, if I did that without referencing the sign of the second derivative on the interval, I wouldn't get credit. Okay? So I have to justify how I knew it was concave up, and we knew it was concave up by looking at the sign of the second derivative. All right, any questions on that piece? All right. right, ready for part C? Ask me a question. Okay. All right, so here we go, part C. What does it say? Find the particular solution. Okay, now guys, don't start solving the differential equation unless it says, very straightforward, solve the differential equation, or find the particular solution. Okay, because in 2015, they gave us a differential equation that was not separable, never asked students to solve it, but many students tried. Okay, if it says let y equal f of x be the particular solution, they're not asking you to find it. Okay, so don't find it until you see find the particular solution or solve the differential equation. All right, so let's do this. dw dt All right, what's the first step, guys? Good. No, that was like my hand getting in the way. Thank you. All right, so first step, separate variables, okay? And if you look at rubrics, you'll see that if you mess up on that first step, you're out of it. Okay? If you don't separate legally, okay, and correctly, then they won't look at anything else you do. Okay, so I usually take the time to just separate the differentials first. So I multiply by the differential in the denominator, and then I take a look at what I need to do next. I think it's worth taking that time to do that separately and now decide, all right, what do I need to move and how do I legally move it? So what do we need to do? Good. So on the left, we would have 1 divided by w minus 300. Now my hand's getting in the way. dw equals 1/25 dt. All right, so do we have variables separated? All right, so now what? Integrate both sides. All right, what is the antiderivative of 1 over w minus 300 with respect to w? Good. Natural log, absolute value, w minus 300. All right, moving to the right side. What's the antiderivative of 1/25 with respect to t? Be careful. It's tempting. One of the top 10 mistakes of the AP exam. I think I talked about that before. People seeing 1 divided by anything and automatically thinking it's a natural log antiderivative. Yep, 1 over 25t. So the antiderivative of a constant is the constant times the variable of integration. And then I have to have plus c. Probably on this one they would overlook it. Turn their head a little bit. Okay. Now, at this point we have options. Okay, you can decide to solve for this constant of integration right away, or you can wait till a few steps later. And I've done it both ways. I've gone back and forth. I think what's your preference? Do you have a preference? You want to do E? Okay, that's typically what I do. I end up not solving for C. I end up solving for that plus or minus e to the c situation. So I don't have to ultimately decide between two solutions. Okay? But I can't, I don't know which way is more efficient. It's preference. Okay? All right, so how do I undo natural log? What's the inverse operation? So exponentiate. So the purpose of choosing that operation is because it's the inverse. Those undo each other, leaving us with absolute value of w minus 300. All right, just be careful over here, because a common mistake is bringing that c out of the exponent. Okay, we got to bring up the c. It's now part of that exponent. All right, and then we're going to use our exponent properties to write this, to rewrite the right side as the product of two powers. So absolute value of w minus 300 e to the 1/25th t times e to the c. Make sure you write that as a product of two powers. All right. What's next? All right, so if we drop the absolute value from the left side, what do I have to do in the same step on the right side? Plus or minus. Is everybody okay if I switch multiplication as commutative? All right, so this is where I go ahead and I decide, all right, I want to go ahead and take care of this situation, this plus or minus e to the c. So this is where I would stop and substitute the initial condition. Yes, ma'am?
So on the other one, we have to do pressure lines, and this one is from the left.
That's good.
So what I did is I don't leave it as e to the c, because e to the c is a constant, so I should
Yep, absolutely.
Let's make sure.
Okay, so, and this is one of the things I ask my students, like, what's your preference? So a lot of times you'll see, even on rubrics, we can say, you know what, it's just a constant. So let k equal plus or minus e to the c, and now I can just rewrite this or use a different placeholder or a capital C. So k times e to the 1/25th t. So yeah, it's still just a constant.
Keeping that as c rather than constant.
Yeah.
As well.
Mhm.
And then
Good.
what I told them for the plus, so since I changed it to c, I said technically there's a plus or minus there, but it's just a constant. We don't know what it is yet, so that's why we drop it and just say c. It's not
Yeah.
k. And then go with it.
Right. Just like if I do 2 times a constant, it's still a constant, right? A constant plus 1, still a constant. Thank you for asking a question. Okay, so we're going to go ahead and, so now in this case, I'm just solving for k. So what's our initial condition? 0, 1400, t, comma, w. So 1400 minus 300 equals k times e to the 0. What's e to the 0? 1, so we just found the value of k, or plus or minus e to the c, 1100. All right, so I go back right there, rewrite that equation, but making a substitution for k. So 1100 e to the 1/25th t. And then one more step to solve for w. We're not done until it says w equals. So we have w as a function of time. So add 300. 1100 t plus 300. Everybody okay? All right, so on a question like this, you want to get the point you know how to get. Okay, so as soon as you see that find a particular solution, you know you're given a derivative, you're trying to get to w, so you've got to integrate. But prior to that, we've got to separate variables. So show the reader what you know how to do. Okay, so separate variables. Once you have variables separated, integrate both sides. Don't forget your constant of integration. What happens if you forget it? Okay, if you forget it, okay, no, we don't look at anything else you do beyond that point. Okay, so if you forget it, like a couple steps later, you realize, oh no, I forgot C. What should you do? Go back, because you don't get credit for a late C either. If you put it on like 2 or 3 steps too late, it's too late. We've already moved on. So if you realize, and it's actually called a late C, okay, so if you realize you forgot it, go back and put it where it was supposed to be. All right, any questions? Isn't this fun? All right, is the next one on here?
Yeah, it is. What's not, we're going to click those little 3 dots.
Okay, a new flip chart? Okay.
And then I think it's 21, not the solution yet.
All right, let's look at this
That's
one.
what I think about, right?
All right, so guys, this is really recent, just a couple years ago. Question number 6. All right, so read the context here, and then do part A at your table. What time is this class over? Okay. So read the context, and then do part A. That's what I say. All right. There's 3 components they look for in the scoring of this. So first of all, make sure you go through the right point. Okay, find the point. All right, 0, 0. So that's our origin here. So we know our curve needs to pass through that point. And then it needs to have the correct basic shape. So clearly, don't draw like this piecewise linear function that some people try to do. And don't draw like it's clearly not linear. So the correct basic shape. And then you want to extend through entire slope field. So check your solution. Did you go through the right point? Okay? Does it have the correct basic shape? So if we kind of like let the tangent lines guide us. Okay, eventually we're going to see this horizontal asymptote situation. And then make sure you use the entire slope field. So extend that solution curve through the entire field. Okay? Yes, that's fine. I won't look at it. All right, part B. Using correct units. Explain the meaning, okay, interpret the meaning of that limit statement in context. Talk about that. Talk about it at your table. Write a sentence.
It means that whenever
So what's
the
A first?
medication-
There you go.
the medication is being put in, as T equals 0, as the person is being, eventually 12 milligrams of the medicine. It means that it's gonna head towards 12 as the hours go by. If that's kind of same thing, but actually 12. As a person thing. Why? Yeah, why? A. How much medication?
All right. I have this in case you'll have questions. Okay, so what is this, guys? We're taking the limit as t goes to infinity. So we're talking about as time increases, okay? As time, we can say in hours, just to make sure, units wise. As time in hours increases, what's happening with A? Okay, it's approaching 12, right? But we got to be in context. So when you read that A of t, remind yourself what that's talking about. Okay, it's defined for us in the prompt. Okay, so the amount in milligrams of medication in the patient. Okay, that's A. So as time increases, as time in an hour increases, the amount of medication in the patient approaches 12 milligrams. Everybody okay with that? All right, so the scoring notes say there's 3 components you have to have. So you have to be in context. So you have to know what A is. So A, amount of medication in this patient. Okay? We have to say it's approaching 12. And then we have to have the correct units. So time's measured in hours, medication's measured in milligrams. Everybody happy with that? All right, part C. What does it say? I love that confidence. I don't like that. So remember, this is a very recent question. So now look at the language they're using. It's like a reminder. Use separation of variables to find y. Okay, so think about what we're given. So we're given dy dt. Dy dt is given. And what are we trying to find? Y. So how do I get from dy dt back up to y? We have to integrate, okay? But prior to integrating, we've got to separate variables, okay? So very recent question, they're giving you that reminder. Separate variables first. What time is it? Okay, you want to just kind of go through this together so we don't run out of time? All right, so first step, separate variables correctly and legally. So what do we do first? Multiply by dt. So I would just separate differentials first and then figure out what to do next. Divide by 12 minus y. So if that quantity is in the numerator on the right side, it'll be in the denominator over on the left side. 1/3. Be careful, because a common mistake is once you move that, people forgetting that 3 is still in the denominator. Okay? Now what? Okay, so 12 minus y, what's the derivative of 12 minus y with respect to y? -1, okay? So technically it's a u sub. Some people can kind of do it in their head, but 12 minus y, so du equals negative dy. So I multiply by a negative on the inside and outside. Okay, so that's why our antiderivative has that negative. So we have negative. Everybody okay with that? So then this right here would be our du, so I have 1 over u with respect to u. So negative natural log, absolute value, 12 minus y. All right, the right side, what's the antiderivative of 1/3 with respect to t? 1/3 t. 1/3 t. And we can't forget our constant of integration. All right, so here, another situation where we have y captured in the absolute value of this natural log. So my preference is to undo those operations prior to finding that constant of integration. So what's the first step I need to undo? The negative. Okay, either multiply by a negative, divide by a negative. So natural log, absolute value of 12 minus y equals negative 1/3 t. And then I typically just say plus c sub 1. It's still a constant, it's just not the same as it was on the previous step. All right, what's the next thing? Okay, so exponentiate both sides to undo that natural log. So e to the negative 1/3 t plus c sub 1. And then I would rewrite that right side as the product of two powers, e to the negative 1/3 t times e to the c sub 1, which is still just a constant. And then I can drop the absolute value, 12 minus y over here, plus or minus. I'm going to use a commutative property to switch the order of those. And then remember, guys, this mess is just a constant, okay? Replace it with c. Is that what y'all usually do? Replace it with c? Oh. 12 minus y. I'm just going to call it k since I've already used c. All right, so that's all I'm solving for is this mess, which I've just cleaned it up to just call it k, as a placeholder for that constant. All right, what's our initial condition? Nice, 0, 0. So we have a time coordinate and the corresponding y coordinate. All right, so 12 minus 0 equals k times e to the 0. So what's the value of that constant? Good. Equals 12. All right, so I go back to that step, rewrite the equation with the exception we make a substitution for k. And we've got to keep going until we solve for y, okay? If you read the question, it wants us to find y, okay, as a function of t. So what do we need to do? Subtract 12 and then divide, or I can add 12 and subtract. So either way you do it, y equals 12 minus 12 e to the negative 1/3 t. Is that right? Okay. Clearly I can't do two steps in one.
You did it correctly.
Oh, I did? All right, you guys tell me what to do. What do we do first? You want to subtract 12? Subtract 12. So the opposite of y is equal to 12 e to the negative 1/3 t minus 12. And now what? So we have negative y equals, so now I'm just going to divide by a negative or multiply every term by a negative. So negative 12 e to negative 1/3 t plus 12. Okay, good?